Multi-agent models apply to the economy. In this video, we will see what are multi-agent models, why it is important in the economy, Schelling segregation model, and random walk model. What are multi-agent models? Although there is no formal and precise definition of what an agent is, there are generally scenes and intelligent entities who exist within a certain context or environment, and it can be communicated through a distributed system in which the nodes or elements are artificial intelligence systems, or a distributed system where the combined behavior of these elements produce an intelligent overall result. It should be noted that agents are not necessarily intelligent. There are, as in the all of the rest of the artificial intelligence domain, two approaches to building multi-agent systems. The first is the formal or classical approach, which consists of providing agents with the greatest possible intelligence using formal descriptions of the problem to be solved and the rest of the functioning of the system on such cognitive abilities. The second is the constructivist approach, which pressures of the idea of providing intelligence to the set of agents so that through ingeniously elaborate mechanisms or interaction, the systems itself generate intelligent behavior that was not necessarily planned from beginning or defined within the agents themselves. This type of demeanor is commonly called emergent behavior. Why is it important in the economy? This model facilitates the study of certain complex phenomena and make predictions related to the future behavior of variables. If reality is very complex, this model will focus on capturing only the variables that are much more relevant than the phenomenon under study, and thus allow better simplicity and understanding. Since they are based on simplified assumptions that relate to variables, their primary uses are: first, diagnose any particular phenomenon or situation; second, design economic policies; third, understand the relationship between economic variables; and fourth, predict the behavior of future variables. Schelling segregation model can be studied through agent-based modeling. The model has two possible types of agents, differentiated by the color red and green, positioned in environment which act under local information for meet the requirements. Meet with these of the same group or color. If these restrictions or requirements cannot be met, then they can move from one place to another until they find a location where they are comfortable in their environment. It is a decentralized system since there is no leading agent to impose certain behavior or guide the process. Self-organization, collective decisions generate new properties in the system on a global scale, leading the systems to exist partners of segregation. It is possible to observe graphically this behavior of agents in the simulator, in which we can modify the parameters of total number of agents, how many types of agents will be taken into account, and the level of satisfaction of agents. The changes are random, so there is no definite behavior partners. However, it is expected that the behavior of agents will end up segregation into birth sets. In this section, I will capture several types of possible combinations at different levels of satisfaction to later run the program and be able to observe the trajectory of the behavior of agents. the ions keep me in a random movement, their segregation is not high, so they maintain a constant behavior as seen in the red and green graphs. Random walk model. The concept of random walk comes from mathematical and statistical study, always based on the collection of time data series that show behavior or historical trajectories. The aforementioned randomness assumes that make response to nonlinear evolution and that they are governed by the laws of nature. Mildly random, that is, the strictly technical and mathematical point of view is not enough to suggest future evolution. However, in economy reality, there are other factors that influence the market, providing in them variation and change the estimates and the actions of the economy agents. There are several programs to be able to perform a random walk simulator, but in this case I will use the URIA program with the extension in Pluto JL. I have added some markers as a title to section the simulator. In addition, this model has a Y parameter. In this section, it is possible to observe that the random change generates a rise when the previous command is returned. This is to modify two graphs, one that projects the trajectory and the second the same trajectory but with markers. To make the behavior more dynamic, I have added a scroll bar to generate the change. Finally, incorporate different trajectories in the same graph. It's all for this video. Thanks for visualizing.